We knew many aircraft engines that have been using for decades. One among those engines is the turbofan engine that powers more than 70% of the aircraft that fly today. What we see here is also a turbofan engine. This is the famous Rolls-Royce turbofan engine. In this presentation, I am going to discuss on various parts of turbofan engine and the way in which thrust is generated by the combined action of various engine parts. Let's move on. Here is a very small introduction on the topic turbofan engine. A turbofan engine is actually a fan jet engine. It is a type of air breathing jet engine used for aircraft propulsion. To boost the fuel economy and to reduce the noise, almost all of today's jet airliners and the military transport aircrafts like C-17 Globemasters and the modern day fighter jets are using turbofan engine. The turbofan consists of the word turbo. It actually refers to the gas turbine, that is the turbo machinery part in the turbofan engine, which generates the mechanical energy from the combustion process. As we're talking about a turbofan engine, it is basically a turbojet engine. An additional fan along with a bypass section make it as a turbofan engine. What we see here is the cross section of a turbofan engine. This is actually the cross section of the G90 family of General Electric turbofan engine. We will go into the various components of a turbofan. This is called as a fan. This is the first component of any turbofan. Here it consists of 16 blades at the major, okay, and the major material that is used for the construction of these blades are titanium, but in this engine the GE uses carbon fiber as a material. The main intention of using carbon fiber is to reduce the weight and to provide high strength. That is the reason behind it. Then the second component is the in the engine core. Actually, in the engine core, the this component is called as a compressor. There are a series of compressors. This compressor is called as a low pressure compressor, and these are called as a high pressure compressor. And after that, we have a series of many layers of combustion chamber, or the combustion of the hot air actually takes place. And after that, these are various turbine blades, or it is called as a turbine, where these turbine blades are made out of single crystal and they are attached to a central shaft. The turbine blades are mainly made out of nickel based alloys. There is also a nozzle that is called as the core nozzle, but we can't see here in this diagram. There is also a nozzle after the turbine blade. What we see here is a free part where no machineries are involved or no moving parts are involved. This region is called as a bypass section. Okay, we can discuss how the air flows inside a turbo fan engine. As the air meets and it meets the fan, and the fan helps in sucking the outside air to two regions. One part of the air intake to the bypass section and the other to the core of the engine. The bypass section, the air moves freely because there are no moving parts, so the air remains so cold. But it is different in the case of the engine core. As the air moves inside the engine core, it meets with compressors. This is a low pressure compressor, and the area of cross section also decrease here. Therefore, as the air enters the high pressure compressor, the pressure will increase due to the minimum area of cross section. And after that, the high pressurized hot air then comes into the combustion chamber where there are 20 nozzles to spray. Many as 20 nozzles to spray the fuel, and it will combine with the fuel. The fuel will combine with the air and gets ignited. After ignition, hot expanding gases will come to the turbine section. So what happens in the turbine section is that with the hot air will turn the turbine blades, and the turning of turbine blades will turn the central shaft that is attached with the turbine blade. This central shaft is then is directly coupled with the front fan and the front compressor. So rotation of this turbine helps in the rotation of this fan and the compressor. And a part of the energy left out from the turbine is then provided as the thrust of the engine. As we say about the thrust of the engine, it is a combination of both the thrust developed from the core of the engine and from the exhaust or the bypass region. So this is all about the cross section of a turbofan engine. In this slide, you can clearly see the various parts of a turbofan engine, and also you can clearly see how the flow of air takes place in a turbofan. So here are the various parts of turbofan, and it's labeled from 1 to 9. There are 9 main parts. First one is a NOZZLE. NOZZLE represents a cover or a layer that supports or it covers the entire engine. That's called NOZZLE. And here the second component is a fan that is made of and titanium blades are there. That's the inlet fan. Then you have a low pressure compressor, it's labeled 3, and here is a high pressure compressor, and there is also a combustion chamber where the combustion takes place. Here is a high pressure turbine, here is a high pressure turbine, and here is a low pressure turbine. This is called as a core nozzle, and this is known as the fan nozzle. Okay. So we are going to discuss on the various components of a turbofan. The first component of a turbofan is the fan. So what you see here is basically a fan of a turbofan engine, and this is the first component of the turbofan, and here it consists of 16 blades. Mostly the blades of a turbofan are entirely made of titanium, but some new engines like the General Electric engines, they are also using carbon fibers as the blade material in order to uh, reduce the weight and to increase the strength of the blade material. Okay, what the basic purpose of a fan is to suck the air from the outside and then speeds into the inside of the engine, that is to the core of the engine and to the bypass section. That is the two parts. First one is the bypass section, and then the other to the core of the engine. So it splits the air, the free air outside the engine. That's the basic purpose of a fan. So as it enters the core of the engine, that core of the engine consists of compressors, combustors, turbine, and nozzle. So the air from the outside reaches the core of the engine, and it passes through compressors, combustors, turbine, and the nozzle. Okay. Then more thrust is developed by the bypassed air that flows through the ducts that surround the engine core. So what is the advantage of the bypassed air is that more thrust can be developed inside the engine. So turbofan engine can develop more thrust. Okay, that is the necessity of a bypassed region. Okay, and this air cools the engine outlet as well as quiet the engine. So the bypassed air can cool the engine outlet. So they can cool the engine outlet and reduce the failures of engine, and also they can quiet the engine. That's the basic purpose of a fan. Okay, here is the second part of the turbofan engine, and that is compressor. So the compressor is the first component of the engine core. As I take the engine core, the first component that the air meets is the compressor. Okay. What you see here in this picture is a compressor, and this is the entire view of the engine core, and the first component is the compressor blades. Okay, and there are a lot of blades attached to a central shaft. So these are a series of compressor blades. Okay, when the air that is coming inlet to the engine is the first meets with the fan, and this fan splits the incoming air into two parts, one to the bypass section and the other to the core of the engine. So the air that enters to the core of the engine first meets with this compressor blades. Okay, so that is the okay, that happens in a compressor. And what happens in a compressor is that the air that reaches the compressor is then squeezed because the area of cross section, as the air proceeds through the compressor, the area of cross section of this compressor comes to a minimized area of cross section will come as the air proceeds. So due to that low area of cross section, the air gets squeezed. That is the air reaches a higher potential, and that high potential air is then forced into the combustion chamber such that the combustion will take place easily. So that's about a compressor. The third part of a turbofan engine is the combustion chamber. The high pressurized air from the compressor is then passed to the combustion chamber, and in that combustion chamber, that air is mixed with the fuel and then ignited. As we know, there are many as 20 nozzles to spray the fuel into the airstream, and thus the mixture of air and the fuel catches fire. This provides a high temperature, high energy airflow. So the exhaust from the combustion chamber will be a high airflow, high energy airflow will be there from the exhaust, and the fuel burns with the oxygen in the compressed air, producing hot expanding gases. So hot expanding gases will be produced. The heat inside the combustion chamber can go beyond 2700 degrees Celsius. For that reason, the entire combustion chamber is made out of super alloys with the refractory metals such as tungsten, molybdenum, niobium, tantalum, ceramics, and ceramic metal mixes to withstand the high heat. Here is the turbine, and the turbine is the fourth component in a turbofan. And in a turbine, there are a series of turbine blades. Hot expanding gases after the combustion chamber enters into turbine, and it rotates the turbine blades that makes the turbine run. The turbine blades are attached to a central shaft where the central shaft is coupled with both the compressors and the front inlet fan, such that the rotation of the turbine causes the compressor and the front inlet fan to spin. So that's how the turbine works. Inside the turbines, what the hot expanding gases, that means the combusted gases or the combust energy from the combustion is then converted to the mechanical energy, and it is is then converted to the rotational energy or the rotational power of the compressor, and then to the inlet fan, and the remaining expanding hot gases are then passed onto the nozzle. And the material used for making the turbine blades are nickel based copper alloys. And also the specialty of the turbine blade is that it is a single crystal turbine blades in order to resist the thermal shocks and to reduce the creep. That is the purpose of making the turbine blade as a single crystal. Single crystal. That's all about turbines. The last component of a turbofan engine is its nozzle. The nozzle is defined as the exhaust duct of the engine. What you see here is an afterburner nozzle. And afterburning is a method of increasing the thrust of the engine for a short period of time in order to improve the aircraft takeoff, climb, or combat performance. This is the engine's main part that generates the thrust. The nozzle may be presided by a mixer, which combines the high temperature air coming from the engine core with the lower temperature air that is bypassed in the fan. Mixer makes up the engine quieter. So mixer is the part that makes the engine quieter, and the nozzle part is entirely made out of nickel inconel and stainless steel alloys. So what we see here is a turbofan engine, a cross section of the turbofan engine, and it is clearly shown how the air flows into the turbofan engine and how the exhaust, how the thrust developed in a turbofan takes place. Okay, then the various parts are also labeled. This is the inlet, the fan, the compressor, the burner section where combustion takes place, core turbine. This is a fan turbine, the nozzle, and the core shaft and the fan shaft, everything are clearly mentioned. And what is here is v. The v is the velocity of the air flow, and m dot is the mass flow rate. What we see here is a free stream, and also uh, okay, m dot is split into m dot c and m dot f. M dot f is the mass flow rate of the air exiting through the fan by bypass section, and m dot c is the air that is entering to the core region of the fan, okay, core engine region. And what happens is that this is the core exhaust region where ve is the velocity of air at the core exhaust, and m dot e is the same, the mass flow rate of the core exhaust. And what we have is m dot c. M dot c is what we call as mass flow rate at the engine inlet, and v naught is the velocity of total air intake, because v naught is split as m dot f and to the core, and as the part of the v naught is split into vf and to the v and as v. So that's what takes place in a turbofan engine. Here are some important terms related to the turbofan engine, and the first is the bypass ratio. Bypass ratio is defined as the ratio of the cold air passing through the bypass section of the engine to that of the hot air passing out the main core of the engine, and that is called as the bypass ratio. Usually for engines the bypass ratio is 80%. The bypass air is used as the engine cooling medium. Okay, so the engine cooling medium is the bypass air. So the bypass ratio is defined is in terms of equation. The bypass ratio can be defined, or it can be explained as m dot c divided by m dot h. Okay, that is the mass flow rate of the air passing through the bypass section to that of the main core of the engine. Or it can be C and H are represented based on the cool air and the hot air, that is the mass flow rate, the cold mass flow rate of the cold air to the mass flow rate of the hot air. That is why it is represented as m dot c and m dot h. Then the term thrust. The total thrust developed by a turbofan is the sum of thrust generated by the fan and the engine core. So both the fan and the engine core develops thrust. So the summation of both the fan and the engine core thrust is called as the total thrust of the engine. And the thrust F is equal to m dot F Vf minus m dot F V naught plus m dot E Ve minus m dot C V naught. So this is an equation, and the corresponding terms, m dot F is the mass flow rate of a fan exhaust, that is a bypass exhaust, and correspondingly Vf is the velocity of air at the fan exhaust, and m dot E is the mass flow rate at the core exhaust, and Ve is the velocity of air at the core exhaust. Similarly, the engine inlet, the mass flow rate of the engine inlet air, that is m dot C, and the velocity of air at the engine inlet is V naught. So these are the terms related to turbofan engine. Here are the advantages of a turbofan engine. First one, there is short takeoff roll. So the roll necessary for an aircraft for takeoff is short, and there is high thrust will be produced, and it has a good fuel efficiency, more efficient flow in fan nozzle, high flight speed compared to the turboprop engines. Here are some disadvantages of turbofan. There is an increase in drag, engine is too heavier, and low speed. This slide shows an engine made afterburning turbofan engine. It is GTX 35VS KAVERI engine developed by the Gas Turbine Research Establishment, a lab under Defense Research and Development Organization. It is now powering the light combat aircraft Tejas of India, and in future it is planned to use in advanced medium combat aircraft. Here are the top turbofan manufacturing companies of the world. First comes the General Electric Aviation of the United States, then the Rolls-Royce, Pratt & Whitney of USA, Gas Turbine Research Establishment under Defense Research and Development Organization of India, Honeywell Aerospace of USA, Eurojet of Germany, and the Saturn of Russia. This is all about turbofan engines. Thank you.